Okay, so this is section 8.3 on chords and arcs. Just go ahead and skip our review because we did this on the last video. So it should be on your last set of notes, these same questions. Okay, so we're going to go straight into the notes. So chords and arcs. Pause if you need to. But two chords are congruent if and only if their arcs are congruent to each other. So we know that chord AB, that segment AB, is congruent to CD. Then we know that the arc AB is congruent to the arc CD, not an O, CD. Okay, and then just a little reminder about notation. So if we have a straight line, that's going to be a segment or a chord. If we have a little arc, obviously that's an arc. Okay. And then we also know two chords are congruent if they are equidistant from the center. So if they are both the same distance from the center, so EF and EG are the same distance, then we know that AB and CD are the same. So AB, CD are going to be the same length. So we can mark those also. And that's for the whole thing. Okay. And then we also know that, just a reminder over here, if there's no segment bar or arc symbol, that means distance or length. So this is talking about the length of those segments. And then equidistant means the same length. Okay. If a diameter or radius is perpendicular to the chord, so perpendicular means we have that right angle in here, right angle and right angle, then it bisects. So remember, bisects means cuts in half the chord and its arc. So if we have on this picture that EH and AB are perpendicular, then we know that AF and BF are congruent and their arcs AH and BH are congruent. Same on the other side. So if CD and EI are perpendicular, then we know CG and DG are being bisected, and CI and DI are being bisected. So those two parts are congruent. And then on our picture from this top part, we know that AF, BF, CG, DG are all going to be the same length, and then all these arcs are going to be the same length as well. Okay, that was a lot of words. So let's get into the examples because it's going to make a lot more sense once we get down into our examples. So number 1, we want to find x. So if we know two chords are congruent, we know the two arcs are congruent. So 7x plus 24 is equal to 115. So then just solve like normal. 115 minus 24 on both sides. So we get 7x equals 91. Divide by 7. We get x equals 13. Okay. Number 2, again, find x. So if we know our two chords are congruent, then our two segments are congruent. So 18x minus 2 is equal to 52. So then just solve like normal. So add 2 to both sides. We get to 18x equals 54. And 54 divided by 18. We get x equals 3. And if we were to take our x and plug it into our equation, then we know that LM should equal 52 once you plug it in. Okay. Flip the page. So number 3. We know that our two arcs, YZ and XY, are congruent. So to find our arc measures, we could do 360 minus 76. So we get 284. That 284 is for both of these arcs left over, okay? But remember, they're going to be the same measure. So what we can do now is take that and divide it by 2. So 284 divided by 2 gives us 142. So this arc is 142, and this arc is 142. Now the equation we can write is that 6x minus 20 is equal to 142. Okay, so subtract this arc from 360, gets us 284. Divide by 2 gets us that 142. Now we can write our equation. So we can add both sides, 20 to both sides. That's our first step in solving. So we get 6x equals 162. And then divide both sides by 6. We get x equals 27. Okay. Number 4, DE is 11x minus 15. FG is 32x minus 27. So because we know that these are perpendicular, and equidistant from the center, then we conclude that DG and FG are congruent. So the lengths are going to be equal. So 11x plus 15 equals 32x minus 27. So subtract 11x from both sides. So we get 21x. Bring everything else down. And then we want to add 27 to both sides. So we get 21x equals 15 plus 27, which is 42. Divided by 21. X equals 2. But we're not done. We want to find DE. Okay, that's our goal. Find DE. Well, we know DE is 11x plus 15. So 11 times our x, which is 2, plus 15 gives us 37. So DE is 37. Okay. Oh, forgot to erase those. So, number 5, in circle Z, RS is 18, and the measure of TY is 42. So I'm just going to label that on my graph, on my circle. So TY is 42. RS is 18. So the whole thing is 18. So that means RW is 9 and SW is 9. Okay, because we know that we have perpendicular and equidistant from the center. We know that RW and SW are congruent. VT and UP are congruent, and all being bisected. So we have all of these properties on our circle. Oh, so I got to adjust mine because I forgot there's already a 1 tick on there. Okay, so now let's go in and fill in what we know. So if this is 9, we can add some more 9s on our circle. And we know that if this measure is 42, then UY is 42 degrees, XS is 42 degrees, and RX is 42 degrees. So there's my circle so far. I'm going to zoom out. So we are looking for TV. Well, we know TV is 9. TU is 18 because that is equal to RS. WS is 9. The measure of our arc YU is 42 degrees. And then make this change. Once the measure of our arc RS, well, that's 42 plus 42, so 84 degrees. Okay, number 6. So I'm just going to zoom in and label my circle. So we know that QM is 6x minus 11. MR is 2x plus 9. And we need to find MN. So our goal is finding MN. First, we need to find X, though, before we can even get to MN. What we know is that JP is bisecting LM and PK is bisecting MN. And we know that LM and MN are the same. So we can conclude that MQ and MR are the same. So 6x minus 11 is equal to 2x plus 9. And then solve like normal. So subtract 2x from both sides. Add 11 to both sides. And then divide by 4. So you get x is equal to 5. Now we want to find MN, so I'm just going to plug in for MR. So 2 times 5 plus 9. So 10 plus 9. We get 19 for MR, but we need MN. So we do 19 times 2. So MN is 38. Okay, so if you need to pause if I went too fast, write that in. Okay, number 7. So first thing I'm going to do is, again, I'm just going to look at what we know. So in our circle, we know this is 5, and we know this is 13. And we are trying to find VW. But if you look right here, we have 2 pieces of known information, and we have a right triangle, which means we can use Pythagorean theorem. We can use that to find ZW. So we have a squared plus 5 squared equals 13 squared. Okay, that's just from this triangle right here. So we have a squared plus 25 equals 169. Subtract 25 on both sides. So we get a squared is 144. Take the square root. We get a is 12. So now we know this segment is 12. But we want the whole thing. And we know that if this is perpendicular, we're being bisected. So these 2 segments are congruent. So we just do 12 times 2. So VW is 24. Okay, now we need to find the measure of our arc YW. So when we're doing this problem, I like to kind of look and see, okay, well, here's our arc. This arc and this angle are going to be congruent. So what we need to find is actually this angle in here. If we look, we have a right triangle with 2 known sides and a missing angle. For that, we can use trig. So I'm going to redraw my triangle over here. So we have our 5, we have our 13, and in here is our x. Using trig, we know that 13 is our hypotenuse, 5 is our adjacent, so we can use cosine. So the cosine of x is 5/13. Now to get an angle measure, you have to use inverse cosine. So x is equal to the inverse cosine of 5/13. So just go ahead and plug that in your calculator. So make sure that you are in degrees. So we have inverse cosine of 5 divided by 13. So our degree measure is 67.4. So 67.4 degrees. Okay. Number 9, so same type of thing. We know in this picture, HK is 30. So if the whole thing is 30, we know that we have 15 and a 15. And PM is 8. So that means that PN is also 8. So now on our picture, we erase those measures we don't need. There is our triangle. So we can use Pythagorean theorem again. So that's our C we're trying to find. So C squared is equal to 8 squared plus 15 squared. Okay, and then take the square root of both sides. So we get C is equal to 17. So if C is 17, that means that pH is also 17. And then for our next question, number 10, we're going to use that same circle. We need to find the measure of our arc GJ. So GJ is this whole arc. So the same type of thing from our last problem, we're going to use trigonometry, because if we have this triangle right here, we know that this angle and this arc HJ are going to be congruent. It's going to be the same degree measure. So if we put an x in here, we know that that x is going to get us this HJ, and then we can multiply that by 2 to get the entire arc that we need. So I'm going to redraw my triangle over here just so it's a little bit nicer to see. I'm going to try and draw it the same way. So it's kind of like this in our picture. You guys see that? That's our H and P. So this is 15. This is 8. And then in here, that's our X. So across from our X, that's our opposite. And then PN is our adjacent. So our equation that uses opposite and adjacent, that's tangent. So the tangent X is equal to 15/8. And then to get that angle measure, we have to use inverse. So the inverse tangent of 15/8 is going to get us that angle measure. So if I put that in my calculator, inverse tangent of 15 divided by 8, we get X is 61.9 degrees. But remember, that gives us HJ. So this is 61.9. We want GJ. So just times that by 2. So 61.9 times 2, we get 123.8 degrees. Okay, and that is the end of section 8.3.